Vibration of continuous systems, V2. Apparatus description. Introduction. Mechanical resonance is the tendency of a mechanical system to absorb more energy when the frequency of its oscillations matches the system's natural frequency of vibration than it does at other frequencies. It may cause violent swaying motions and even catastrophic failure in improperly constructed structures, including bridges, buildings, and airplanes. When designing objects, engineers must ensure that the mechanical resonant frequencies of the component parts do not match driving vibrational frequencies of the motors or other oscillating parts, a phenomenon known as resonance disaster. Avoiding resonance disasters is a major concern in every building, tower, and bridge construction project. As a countermeasure, shock mounts can be installed to absorb resonant frequencies and thus dissipate the absorbed energy. The Taipei 101 building relies on a 730-ton pendulum, a tuned mass damper to cancel resonance. Furthermore, the structure is designed to resonate at a frequency which does not typically occur. Buildings in seismic zones are often constructed to take into account the oscillating frequencies of expected ground motion. In addition, engineers must ensure that the mechanical resonant frequencies of the component parts do not match driving vibrational frequencies of the motors or other strongly oscillating parts. Angers Bridge was a suspension bridge over the main river in Angers, France. It was built between 1836 and 1839. The bridge collapsed on April 16, 1850, when 478 French soldiers marched across it in lockstep or military marching. Because the soldiers were marching together, they caused the bridge to vibrate and twist from side to side, dislodging an anchoring cable from its concrete mooring. Though a thunderstorm occurred during the collapse, engineering reports at the time indicated that the collapse was due to the soldiers rather than the storm. Some 226 soldiers died in the river below the bridge. As a result of the bridge's collapse, marchers were advised to break step when crossing bridges, a reiteration of much earlier advice given to Roman soldiers. The Angers Bridge was not the first suspension bridge to collapse. Previous failures included Dryburgh Abbey Bridge in 1818, the Royal Suspension Chain Pier in Brighton in 1836, and damage caused by winds to the Menai Suspension Bridge in 1825, 1836, and 1839. The electrodynamic vibration test system used in this testing apparatus is comprised of an electrodynamic exciter or shaker, a power amplifier which drives the exciter, a function generator to select the required frequency, and an oscilloscope for vibration monitoring. The apparatus of this experiment consists of a rectangular aluminum beam pin-jointed at both ends and carrying a sliding mass which can be positioned along the beam. The location of this mass varies in each experiment. This system is supported by a small frame and attached to the vibration exciter. The vibration exciter unit delivers the force vibration to the beam through a rotating unbalance mechanism. Instrumentation. Photonic sensor. A photonic sensor is a device used to measure amplitude of oscillation. By emitting a ray of light and measuring its reflected intensity, the amplitude of oscillation can be determined. The intensity of light is related to the distance between the beam and the sensor. The reflected light received by the sensor is converted into an analog voltage signal. By sending this signal to an oscilloscope, a trace is produced which is related to the displacement of the beam. The photonic sensor is a nonlinear device that behaves linearly in certain regions, such as CD and EF. The sensor should be operated in region CD in this experiment. The photonic sensor is turned on by a control unit attached to the apparatus frame. The photonic sensor is attached to a screw mechanism which can travel horizontally above the beam. It is important to ensure the sensor head does not touch the beam,